Alright, so what we're going to look at here are we're going to take these concepts that we learned with, making systems of equations and whatnot, and we're going to use them to develop, we're going to get systems of equations by looking at word problems. So, there's a lot of word problems in mathematics, and often what you'll see is that systems of equations can be constructed from word problems. And we already know how to solve them. We just use elimination or substitution to solve this system to answer the question. So we're going to look at three types of word problems in this section. We're going to look at value, interest, and mixture problems. The first type of problems, we're going to look at our value problems. So, value problems. Okay, well, these first few problems involve, they involve a bunch of items, whether they be coins, tickets, shirts, whatever, each with different prices. The goal here is to find the total value of each of these items. So, how do we figure this out? Well, this is just from common sense, right? If you go to the movies or whatever, and you want to buy 6 tickets, and each ticket costs $15, how much are you going to spend? Well, you're going to multiply them to get $90. We do this all the time in everyday life. This is just common sense. Duh. Literally. It's just common sense. But the thing I want you to notice here is this is the structure that these problems are going to take. They're going to take a basic structure where you have something times something equals something. Okay. And this formula, which we'll talk in more detail very soon, is the basic structure for developing these systems of equations in these word problems. And that's exactly what I'm going to do here. I'm using that above formula to construct a systems of equations that I need to solve. And that'll allow me, that'll be regarding the total value of a particular item. Alright, so for most of these word problems that I have, what I'll be doing is I'll often arrange these equations in a table. You don't have to use a table. You don't have to use a table, but I find them very nice because they're convenient for organizing information in the problems. And that leads me to this last thing here. There is no general rule for telling which of these things you have to do. You have to think about what the problem is telling you. In my particular opinion, I think constructing a table to organize this information in a word problem is very efficient. It's convenient, it organizes the information, and then you could follow along pretty easily. That's my opinion. But everybody's different. So, here's how these problems are going to be constructed. So, these problems are going to be constructed by the following. So, using that basic formula, right? The number of stuff you're buying, the number of things you're buying will go in the first column of the table. That would be the number of tickets, like we looked at, number of times it makes a trip, or the time it takes to make a trip, the amount of money in an account, and so on. The value per item, or rate, will go in the second column. Okay? So that's like the cost per ticket, the speed of a car, the interest rate in a bank account, and so on. And then finally, the total value or total amount will go in the third column. That might be the total cost of all the tickets, the distance traveled by a car, the total interest of the investment, whatever. So with this arrangement, set up this way, using that basic formula I was talking about, right? It's going to be the number of things, right? So the number of things, oh, I can't even spell things. The number of things times the cost of the thing equals the total value of the things altogether. So take this, multiply by this, and that equals this. So with this arrangement, that's going to be the first column times the second column equals the third column. If I refer back to the first page, that stemmed from this basic example. The number of things, the cost of each of those things equals the total value. If I buy 6 tickets and they cost $15 per ticket, the total cost is $90. And that is the basic structure of the formula that we use for these word problems when we're looking at total value. It just depends on the problem. So if I look at this example, right? So a Katy Perry concert will play at an auditorium that has 400 balcony seats and 1,600 main level seats. If tickets for balcony seats will cost $15 less for main level seats, what should be the price for each type of ticket so that the total revenue from a sellout performance will be $70,000? Alright, so I arranged a table beforehand in the notes just to keep things more organized. So the first thing you want to do when you're looking at these problems is you want to identify the unknown value. What is it you're trying to answer? What are you trying to answer in the problem? So I'm going to underline it. The unknown is this right here. What should be the price? What should the price be for each type of ticket? So the unknown variable, the thing we're trying to solve for, right? What should be the price for each type of ticket is the price per ticket. So the unknown variable is the price per ticket. I just put a dollar symbol there to indicate price. So that's the price per ticket. That's the unknown. That's what I'm trying to figure out. Need to answer. Right? Okay. So now that I've identified what it is I'm trying to find, I'm going to define those variables. So if you notice in this problem, I have 2 different types of tickets. I have balcony seats and main level seats. All right? I have 2 different types of tickets. So I'm going to have 2 different variables for each type of ticket. All right? So I'm going to define some variables for the unknown. But I have 2 types of the unknown, so I got to define a variable for each. So let's do that. So the balcony seats, so I'm going to let the variable B for balcony, go figure. Let B be the price per ticket for balcony seats. And I'm going to let M be the price per ticket for main level seats. All right. So because they're my unknowns, right? The price per ticket's my unknown variable. So I'm letting B be the price per ticket for the balcony seats. I'm letting M be the price per ticket for main level seats. Okay. So now that I know that, I'm going to fill it in my table. What is the price per ticket for balcony seats? It's B. What's the price per ticket for main level seats? It's M. Now I'm writing it a little to the left here because I might have to fill in something here, but I'm just giving myself enough space. That isn't always the case, but it's always a good habit. Okay, now, since that's the unknown quantities I'm trying to figure out, everything else, the number of tickets and the total value of the tickets, that should be given information in the problem. I just got to identify it and fill it in. So, how many tickets are there of balcony seats? Does the problem say that? It should. It does. Right here. An auditorium has 400 balcony seats. So there's 400 total balcony seats. And there's 1,600 main level seats. So there's 1,600 main level seats. Okay. Well, so the total value is going to be what? What's the total value of the balcony seats? Well, that's going to be the number of tickets times the price per ticket. That stems from this formula, right? The number of things times the cost of a thing equals the total value of that thing. So the total value of balcony seats is going to be this column times that column. First column times second column equals third column. First column times the second column equals the third column. Okay, so 400 times B is going to be 400B. And 1,600 times M is going to be 1,600M. What's the total value of all the tickets together? So the total value of both tickets is going to be this entry right here, right? Because they overlap right there. So the total value of all the tickets should be right here. Does the problem give me that information? Yes. If I'm going to sell, the total value of all the tickets being sold is going to be $70,000. That's a sellout performance. So that means all the tickets will be sold. So this would be $70,000. All right. Is there anything else from the problem that gives us any information? There is, actually. And if you look right here, I'll denote it in blue. It's right here. If tickets for balcony seats will cost $15 less than tickets for main level seats. That tells you something about the relationship between balcony seats and main level seats. Alright? So that means the balcony seats, right, will, or I could say will, cost $15 less than main level seats. Alright, so that means balcony seats are equal to, this just means there's a relationship between balcony seats and main level seats. This means balcony seats will, so that's the equal sign, will cost $15 less than main level seats. So how do I write, so that means I'm going to have $15 less than the variable M, right? Because that's what main level seats are. The price for a main level seat is M. And at $15 less than that is going to be, how do I write that? I'm going to write M minus 15. So that's going to be M minus 15. This means balcony seats cost $15 less than main level seats. This doesn't always show up in these problems, but it's important to dissect every piece of information from these word problems and fill them in the table. And then that way you can get your equations. Okay, so what I could do now is I could derive my equations. I filled in the whole table, right? I filled it in. You could put 2,000 here to indicate 400 plus 1,600 is 2,000, but again, that may or may not, you know, that may not mean anything. It's just, that's up to you. So, all right. So my equations are going to be the following. So my balcony seats is 400B plus the total value of my main level seats, which is 1600M, equals the total value of selling out the entire theater, which is $70,000. There's one equation. Where am I going to get the second equation? Well, it's right here. It's the relationship between the balcony seat price and the main level seat price. And that's going to be B equals M minus 15. So this right here is my system. This right here is my system of equations. Now, you could, if you wanted to, you could replace the B right here with M minus 15 in it right off the bat. So I'll say here just for reference, or you could write it this way. 400B plus, oop, I goofed already. Sorry. You could write it as 400 times, so instead of writing 400B, you could write 400 times the quantity M minus 15. You could write it like that, right? And you just replace this with B right off the get-go. And then plus 1600M equals 70,000. You could either do it this way or this way. Either one is going to be fine. It said, you know, if I solve this system, I'm going to be doing the substitution method anyway, so I'll be plugging this in right here, and I'm going to get right over here. So I'm really just one step further by doing this. But that's how you get your equations. You could either do this or this. All right, so now solve. All right, so now when you solve it, you're going to take this and plug it in here for B. You're going to get that. Now, like I said, you could get that from here, or you could start from here, and you will get there. Either way, you're going to get here. So when you solve it, you're going to have, so you could take this and plug it in there, right? Just take B and plug it in here. You're going to get that. So now when you solve this, how do you solve this? Distribute the 400. 400M minus, now, if you want, you could use your calculator. So 400 times 15 is 6,000. So that's going to be minus 6,000 plus 1600M equals 70,000. 400M plus 16, I'm going to combine the M's together. That's going to give me a 2,000M. Minus 6,000 equals 70,000. Right? Again, all I did here was distribute, combine like terms. Now I'm going to add 6,000 to both sides. Then I'll get rid of this. So now I'll have 2,000 M equals 76,000. Now just divide both sides by 2,000. And you're going to get M equals, so 76,000 divided by 2,000, 38. So M equals 38. So I figured out what one of my unknowns should be. M should be 38, right? So M is the price per ticket for main level seats. So if M is 38, how do I find B? Well, the relationship is right here, M minus 15, because it's supposed to be $15 less than that, right? So I'm going to have 38 minus 15, which is what? 23. All right. So, to answer the question, what should the price be for each type of ticket? Well, main level seats should cost $38. And balcony seats cost $23. And that's it. Main level seats should be charged $38 and balcony seats should be $23 if I want to sell out this theater to get $70,000 in revenue when you have 2,000 seats. Alright, so that's all these kinds of problems. They have a very similar structure. The structure is very, very similar. Figure out the unknown, identify the unknown, give it a variable, fill in your table, derive your system or your single equation, solve that system, answer the question. It's a very formulaic setup. It's a very algorithmic setup, step 1, 2, and so on. So, yeah, nothing too tricky there, in my opinion. This one's even easier. So, excuse me. So a 5,000 seat theater has tickets for sale at $27 and $40. So how many tickets should be sold at each price for a sellout performance to generate a total revenue of $150,600? Again, what is the unknown quantity? What are we trying to figure out here? How many tickets should be sold at each price? That's the unknown. The number of tickets sold. So I have two different types of tickets. So I'm going to define each type of ticket. I'm going to define the number of tickets for each type with a variable. So I'll just use X and Y. I'm going to let X be the number of $27 tickets. I'm going to let Y be the number of $40 tickets. So now that I know that, fill it in. So fill it in. So where is this going to go? It's the number of tickets. So the number of tickets is the unknown here, not the price. So I'm going to put X be the number of $27 tickets. So X is going to go here. I'm going to let Y be the number of $40 tickets. So that's going to go here. Now, does the problem tell us, so now that I have the unknowns filled in, I want to fill in the rest of the table with information from the problem, the known information. Okay. Does the problem tell us the number of tickets in total? It does, right here. A 5,000 seat theater. So there's a total number of 5,000 tickets that could be sold. Alright, well, what's the price per ticket for a $27 ticket? Duh, that's easy, $27. And the price for a $40 ticket is $40. So again, the total value for $27 tickets is going to be column 1 times column 2. X times 27 is 27X. Y times 40 is 40Y. And what's the total value of all the tickets. So the total value to sell all the tickets should generate $150,600. All right, so now let's make our equations. Our system, I should say. So our system of equations, so here's one equation, 27x plus 40y equals 150,600. Where's my other equation? Well, right here, right? X plus y is 5,000. Right? The total number of $27 tickets and $40 tickets should add up to 5,000 tickets altogether. Here's my system. So now solve that system. All right. So how are we going to solve this system? Well, again, we have two methods, substitution or elimination. We used substitution, and we could certainly do it here as well. We could solve this for y or x and plug it into the other one. Or we could do elimination, like we did in 3.2. We can multiply the second equation by negative 27, or we can multiply the second equation by negative 40. Add them together, and one of the variables will cancel out. Either way you do it is fine. Either way is fine. I'm going to do elimination. So I'm going to multiply the second equation by negative 27, just because I feel like it. So when I do that, there's the first equation. Multiply the second equation by negative 27. I'm going to get negative 27x. Negative 27 times y is minus 27y equals, and negative 27 times 5,000. Calculator time. Negative 27,000 times 5. Or yeah, negative 27 times 5,000 is negative 135,000. Add the equations together. What happens here? The 27x's cancel, as they should. So now, 40y plus negative 27y, which is the same thing as saying 40 minus 27, is 13. So 13y equals 150,600 plus negative 135,000, or I could just say minus 135,000, is 15,600. Divide by 13. 13's cancel. Now I get y equals, so that divided by 13 is 1,200. All right, so I should sell 1,200 of the Y type of tickets. What was Y? It was the number of $40 tickets. All right, well, so how many X tickets should I sell? How do I figure that out? Well, I have an equation right here. I can plug this into either this equation or this one. I'm going to do this one. That one's much easier. So if I solve this for X, right, I just subtract Y. Right. Y was 1,200, so 5,000 minus 1,200 is 3,800. So to answer the question, how many tickets should be sold at each price? Well, so X was what? X was 3,800, so 3,800 tickets at $27, and 1,200 tickets at $40. Easy peasy, nothing to it. You can see how these problems are very, structurally they're very similar. They really are. Alright, so we're going to move on to interest problems now. So the only difference with these types of problems is the formula we're using. That's really it. When we were doing total value, we were looking at, the total number of stuff times the price of the stuff gives you the total value of the stuff. Well, now, when we're looking at simple interest, which is a basic formula, if you invest an amount, we call this the principal. So that's the principal. And it pays 4% interest. So if I multiply the principal times the interest rate, which we denote R, that's going to equal the interest. This is simple interest right here. That's as basic as it gets when it comes to interest rates. It's the principal times the rate equals interest. So in this example here, if you invested $600 and you multiplied it by the interest rate, which is 4%, so it's 0.04, you're going to make an interest of $24. So your principal plus the 24, now you have $624 in your account. That's basic interest, baby. If you take college algebra, you'll see other types of interest. You'll see compounded interest, continuous interest. I don't want to get ahead of myself, but yeah. Okay, so if you look in this example here, so this formula takes structure here. The amount, that's the principal, right? Interest rate, that's R. And interest is I. So principal times rate equals interest. There's that formula. Alright, so in this problem, a person plans to invest twice as much money in an elephant account at 2.7% annual interest as in a Vanguard Morgan growth account at 5.5% annual interest. How much will the person have to invest in each account to earn a total of $218 in 1 year? Alright, what's the first thing we do? Identify the unknown value. It's right here. How much will the person have to invest in each account? Alright, that's the unknown. So how much? So that's the amount invested in each account. Since I have two different types of accounts, I'm going to have two variables to identify each. So I'm going to I'll just use X and Y again, it doesn't matter. I'll let X be the amount invested at 2.7% interest, and I'll let Y be the amount invested at 5.5% interest. Alright, so now that I know that, since I've identified these unknowns, let's fill it in. So the amount at 2.7% is X. and the amount invested at 5.5% is Y. Again, I'm just giving myself some space in case I have to write like an equal sign in here, and as it turns out we do, but we'll get to that. Alright, so let's fill in the rest of the table. This should say total here. I guess I forgot to type that in when I made the notes, but anyway, let's fill in the rest of the table. So what's the interest rate at 2.7%? Well, 2.7%, I got to write that as a number. So how do you write a percentage as a number? You move the decimal point to the left twice. So when I move it over here and then over once more, it's going to be 0.027. How do I write 5.5% as an interest rate? Move the decimal point to the left twice. So that's going to be 0.055. Okay. What's the total interest? What's the total interest? That's going to be this corner entry here. The total interest for both accounts in 1 year. Well, I want to earn a total of $218 in 1 year. I want to earn a total of that. I want to earn that much interest between my both accounts. So that's going to be the total interest. All right. Is there any more information in my problem? So right here, a person plans to invest twice as much money in an Elephant Trust account at this percent as in that account at 5.5%. So they want to invest twice as much money in this account as in this account. So that means the relationship between, they want to invest twice as much money in this account in 2.7% as in 5.5%. So they want twice as much money in here as they do here. So if I read this problem carefully, they want to invest twice as much money here as they do here. So this, right, is going to be what? So they want to invest twice as much money. So that's going to be 2 times what? Well, it's going to be 2 times. So if I read the problem, right, they invest twice as much money at 2.7% as in a Vanguard Morgan account at 5.5% annual interest. So twice amount in this account as in this account. Okay, so that means I'm going to have 2x or 2y. Which one's it going to be? Well, if you read the variable's description, we're letting x be the amount invested at 2.7% interest. So if I'm investing twice as much money at 2.7% interest, that means I'm investing twice that amount at 2.7%. The amount is x, so twice that amount is going to be x. I put an equal sign here, not to indicate that x is equal to 2x, because obviously it isn't. But I just want you, maybe an arrow sign would be more, maybe an arrow sign would be better, but yeah. So sorry about that little hesitation there, but I was thinking about how I wanted to write that. So just be aware that this right here is what we're using. And this right here as well. Okay, so the hard part, well, the tricky part is over. It's interpreting that statement and writing it as a variable expression. Now we just got to figure out our equations. So actually, you know what? Let me rephrase this. Well, no, it's not that this is wrong. Our equations are going to be well, I know this one's going to be 0.055 times y. This one I'm going to write as 0.027 times x. Just bear with me for a second. So when I add this column up, I'm going to get one equation as 0.27 x plus 0.055 y equals 218. That's one equation. Now the next equation I can get is the relationship between the amount invested in one account versus the other. So this right here is a little goofy. Let's flesh this out a little bit. So a person plans to invest twice as much money at 2% annual interest. So let's just write that down. Twice as much money at 2%. Well, if x is the amount invested at 2.7%, my video froze, hold on. So if x is the amount invested at 2.7%, and I want to invest twice that much money, so that's going to be 2x, right? So let me just write that. So the relationship between twice this much amount is related to how much I invest in my 5.5% account, which is that. Actually, no, it's not. I'm missing something here. I'm sorry about this. Sorry about this, guys. Just give me a second. Let me think about it. A person plans to invest twice as much money in an Elfin Trust account at 2.7%. So if they're investing Y here, they're investing twice as much there. Okay, I think I figured out what it is. I made a little mistake. Just bear with me. Yeah, so I figured out what I did wrong. I'm sorry about that. I made a mistake. I switched the variables in my head by accident. Just a stupid mistake. This shouldn't be 2x, this should be 2y. So this should be x equals 2y. And I'll explain why in a minute. Well, right now, actually. So, if you think about it, if I'm investing this much amount at 5.5%, I'm investing twice that amount at 2.7%. So if I'm investing y here, then twice that amount will be 2y. That's it. I just overthought that part for some stupid reason. So my equations, so this equation is correct. And my second equation is going to be x equals 2y. I had it the other way around. When it should have been, I had it as y equals 2x. It should have been x equals 2y. My mistake. So those are my equations. Sorry about that confusion. You just got to read through the problem carefully and, you know, analyze it as carefully as possible. But if you think about it, I'm investing y amount at 5.5%. So I'm investing twice as much in this account that I did here. If I'm investing y here, and twice as much of that money is going to be 2y. The wording up here got a little weird. Okay, let's solve this system. So again, I could just take x and substitute it for 2y up here. So I'll have 0.027 times, so x is now going to become 2y plus 0.055 y equals 218. 0.027 times 2 is 0.054 y plus 0.055 y equals 218. So 0.054, just be careful with these decimals, plus 0.055 is 0.109. So that's going to be 0.109y equals 218. So now to solve that for y, divide by 0.109, and you're going to get y equals 218 divided by 0.109. Gives you 2,000. So you know that when you divide that number by this ugly number and you get a nice number, you know you did something right. That's not always the case, but in these problems it is. So that's the amount y. What's the amount in x? Well, it's going to be twice that amount. 2 times 2,000 is 4,000. So to answer the question, how much in each type of account? Well, so x was the amount at 2.7%, so $4,000 at 2.7% and $2,000, which was the y amount, at 5.5%. That's it. Sorry about that stupid little thing I did. I wrote 2x, I should have wrote 2y. I had it in my head, but for some reason I don't know, I just goofed it up. I make mistakes myself. But yeah, that's the problem. If you're confused about this at all, just let me know. But Yeah, that's the problem. So I have one more problem in this section, and I'm going to look at mixture problems. So a mixture problem, again, they stem from a very basic, the similar idea. This is the amount of stuff times the percentage equals the total amount of that particular percentage. So this is like if I have a mixture. Like, you know, you study things like this in chemistry or physics, right? If I have a solution or a collection of objects in a set, whatever. You know, sometimes we look at mixtures of different substances, like liquids. So if I have 50 pounds of an alloy is a mixture of different kinds of metals. So if I have 50 pounds of an alloy, 20% of that alloy is silver, then how many of that alloy is silver? Well, 10 pounds. The other 40 pounds are some other type of metal. So, you know, a chemist. So if I look at this problem, all right, they're trying to figure out how many, right? So I'll just kind of go through this example a little faster because you're familiar with the process by now. So the unknown is how many quarts of the 15% acid solution. So my unknown is number of quarts, right? So okay. So let my unknown, so I'm going to let, so if you look here, how many quarts of the 15% acid solution? So I only have one unknown here, which is interesting. So how many quarts of the 15% acid solution? So I'm going to let X be the number of quarts of the 15% acid solution. That's my unknown. So because I know that X is going to be the number of quarts of the 15%, I'm going to put that right here. So now let's figure out the rest of the table. Let's fill in the rest of the table from the information on the problem. So do I have the number of quarts of a 25% acid solution? Actually, I think I do have two unknowns. Yeah, how many quarts of the 15% acid solution should he mix with the 25% acid solution? Yeah, my bad. So let X be the number of quarts of the 15% acid solution. Let Y be the number of quarts of the 25% acid solution. Again, when you have two types, you're going to have two variables. Most of these problems had that, and this one's no exception. My bad. I know I said there should be only one unknown here, because no, it's how many quarts of the 15% mixed with the 25%. So Y is the number of quarts at 25%, so that's going to be Y. What's the number of quarts of the 17% acid solution? Well, it's actually written in two different sections here. A chemist needs 5 quarts of a 17% acid solution. He even says it here. 5% or 5 quarts of a 17% acid solution. So that's 5. Alright, what's the percentage of the solution type? So that's easy. It's a dead giveaway. 15% as a percent is 0.15. 25% is 0.25 and 17% is 0.17. Now the pure acid is going to be the number of quarts times the percentage of the solution. So here it's going to be 0.15 times X. This is going to be 0.25 times y. And if you did the math here, 5 times 0.17 is going to give you how much as pure acid. So 5 times 0.17 is 0.85. So my equations is going to be 0.15x plus 0.25y equals 0.85. And where's my second equation? It's the number of quarts. Number of quarts of 15% plus the number of quarts at 25% equals the total number of quarts of my desired solution to be 5 quarts. So there's my system. Now to solve it, again, very basic. You could use substitution or elimination. You could multiply by negative 0.15 or negative 0.25, add them together. Or you could take this and solve it for x or y and plug it into the first one. It doesn't matter. I'll do substitution. I'll solve this for y. So subtract x from both sides, so you're going to get 5 minus x. Take that and plug it in here for y. So 0.15x plus 0.25 times the quantity 5 minus x equals 0.85. So 0.15x plus, now 0.25 times, distribute the 0.25. That's 1.25. And then 0.25 times negative x is negative 0.25x. And that equals 0.85. Combine the x's together. 0.15 minus 0.25 is negative 0.10x. Plus 1.25 equals 0.85. Alright, so now to solve this, subtract 1.25 from both sides. So I'm going to get negative 0.10x. So 0.85 minus 1.25 gives me negative 0.40. And finally divide that by negative 0.10. That's going to give me x equals, so this divided by that, four. So x is 4. X is 4. You can see pretty easily that what adds up with 4 to get you 5? 1, right? So that means y is equal to 5 minus x. We just found out x to be 4. That's 1. I know my 5s look ugly. But, so to answer the problem, so how many quarts of each type of percentage do we need? So we need 4 quarts of 15% acid and 1 quart of 25% acid. I'll just say solutions. And that's it. So again, you know, these problems are very, very similar in structure. Whether you're dealing with total value, total interest, total mixture between things, you know, they're not very different in their structure. They're very identical. But I kind of goofed here. I'm really sorry about that. Should have wrote 2y here initially, but I hope that didn't hurt you too much in your understanding of that. But if it did, don't be afraid to ask me. So yeah, these word problems, whether you're dealing with value, interest, or mixture, they all stem from a very basic formula. So yeah, setting up the table, in my opinion, is the trickiest part of this, but it's really not that tricky. I like using tables because you don't have to think about the formula. You can just fill it in and use the table. The formula just comes out of the table. Alright, so yeah, so when it comes to interest and when it comes to word problems with systems of equations, that's it for this section. So yeah, that's the end of the video.